Hello everyone, welcome to CBSE Topper Series, and the topic that I'm starting today is solid state. It is one of the important topic. Its weightage in your CBSE class 12th is 4 to 6 marks, right? So the first topic that I'm going to discuss is, guys, types of solid. So first thing is what kind of question they ask from this particular topic. So first question they ask is for 2 marks, that is, what are the difference between crystalline and amorphous? And on other hand, the second type of question that they can ask, they can specifically target a specific point from this difference, and they can ask you to explain that particular concept for 1 mark, right? So let's begin, guys. As you can see on the screen, there are 2 types of solid, that are crystalline and amorphous. One is crystalline and one is amorphous, right? Now what is crystalline and what is amorphous? So the first point you can see is that their crystalline solid, as you can see, they have definite characteristics. They have definite characteristic geometrical shape. Their shape is definite. If we are having a crystalline solid, their shape is definite. Their shape is definite means the arrangement of atoms in case of crystalline solid is quite regular. It's a regular arrangement, right? But on the other hand, if you see about amorphous solid, so what about amorphous solid? So you can see their shape is irregular shape. They have irregular shape. And why so? So their shape is irregular because of irregular arrangement of their constituent atoms, ions or molecules in their crystal lattice, right? So first is crystalline has definite characteristic, definite shape, whereas amorphous has irregular shape, and this is due to because in crystalline atoms are arranged in a definite manner, whereas in amorphous atoms are arranged in irregular manner, right? So you can see the structures also. I'm showing you the structure. This is the structure for a crystalline solid. So as you can see here, the arrangement of atom is quite fixed, and because of that fixed arrangement, we are getting a definite geometry out of crystalline solid. But on the other hand, if you see the amorphous solid, so in amorphous solids, the arrangement of atom is irregular. You can see that it is not a fixed arrangement, it is irregular arrangement. So this is about amorphous solid, right? So with this only one point in our head, that this is fixed arrangement, this is not fixed arrangement, we can understand all other differences very easily, right? So the next difference is that is, can you see that? That is melting point, right? Melting point. Now guys, basically one solid will have fixed melting point or sharp melting point. I will tell you what is the meaning of sharp melting point. And the other solid will have, guys, melting point. Thus for other solids, the melting point will lies in a range. What is the meaning of that? So if I ask you very simple question, what do you think who will have a fixed melting point or sharp melting point? So guys, you can relate it to the atoms, where atoms are fixed in a regular manner. Atoms are fixed in a regular manner in crystalline. It means the fixed melting point or the sharp melting point is for crystalline solid. Now the question arises that what is the meaning of sharp melting point? So the meaning of sharp melting point is, suppose I'm giving you a crystalline solid and I'm saying it that it will melt at 120 degrees centigrade. So when you will reach that temperature, only at that temperature melting will start. It won't start before 120 or after 120. It will exactly start on 120. This is the meaning of sharp melting point, and this is a property of crystalline, right? This is a property of crystalline. What about amorphous? Amorphous, on the other hand, in amorphous, the arrangement of atom is irregular. So we can say that the melting point won't be fixed. This is how we can relate. Melting point is not fixed. Melting point lies in a range. What is the meaning of range? Suppose I'm giving you amorphous solid, and one of the wonderful example of amorphous solid is glass. I'm giving you the glass. So when I will give you the glass, I cannot tell you the sharp melting point. I have to give you the range of melting point. I will say that, okay, its range of melting point is between, let's say, 170 to 200 degrees centigrade. Its range of melting point is between 170 to 200 degrees centigrade. Okay, I'm just taking a rough examples, right? So I'm giving you the range. I'm not giving you the sharp point. I'm just giving you the range. And what is the reason for that? Irregular arrangement. Very good. So 2 points we understood, right? Now the third point that we can see is that, all right, cleavage property. Now what is the meaning of cleavage property as written in NCERT? Cleavage property. So guys, as you can see the structure, right? You are seeing the structure on your screen. This is crystalline solid and this is amorphous solid. Cleavage property means, suppose I'm cutting this crystalline solid into 2 halves. At the same time, I'm also cutting this amorphous solid into 2 halves. Now you tell me, who will cut perfectly. So that would be crystalline. Since atoms are arranged in regular manner, so when you cut crystalline, you will get smooth surface because all the atoms will cut in equal portion, right? But on the other hand in amorphous, atoms are not arranged in regular, so when you cut amorphous, then the surface is not smooth. It's not smooth. Why? Because when you cut amorphous, since atoms are not arranged in regular manner, atoms won't cut equally. They won't cut equally. Some atoms will cut more, some atom will cut less. So that is why you won't get a smooth surface. So sharp cleavage is shown by or we can say that smooth surface after cutting is shown by which kind of solid, guys? Crystalline. And it is also linked with fixed pattern. It is also linked with fixed pattern of atoms. Understood? 3 points are clear, right? There is no need for you to write the bookish language. Whatever is written in NCERT, it doesn't require. You need to understand it conceptually. That's it, right? So 3 points we discussed, and the basis of all these 3 points are fixed pattern, right? Now the fourth point is, can you see that? Fourth point is, guys, heat of fusion. Now first of all, let me explain to you what is the meaning of heat of fusion, right? So heat of fusion, you know from your childhood days, right? Heat of fusion is a very popular definition in 9th standard and 10th standard. And what is the meaning of heat of fusion? What amount of heat is required to melt a solid? If you have a solid, 1 mole solid we can consider, and you want to melt it, so the amount of heat that is required is called heat of fusion. Now my question to you, listen to my question properly and answer it. Who will have fixed heat of fusion? Will it be crystalline or will it be amorphous? Then you're like, sir, in crystalline, sir, atoms are fixed. Atoms are arranged in a fixed pattern, sir. It means that crystalline will have fixed or specific heat of fusion. You are right, my dear friends. Yes, for crystalline, we have fixed heat of fusion, but for amorphous, it's not fixed. It's not specific, and that depends upon the arrangement of atoms only. Clear, guys? So 4 points we discussed. Now come to the fifth point. So fifth point I will explain to you, but first of all, in order to understand this anisotropy, we need to understand the last point that is given in NCERT is that crystalline solids, very very important point. I will explain to you properly. Crystalline solids have long range order and amorphous solids have short range order, right? Now what is the meaning of this long range order? So what is the meaning of long range order, guys? Long range order means the specific pattern of atoms. As you can see on the screen, this is a specific pattern of atoms, right? There is one circle, then there is one dot, means this is a type of arrangement of atoms, right? Circle, dot, circle, dot, circle, dot, right? So this kind of arrangement of atoms, in particularly in crystalline solid, will repeat itself for a long distance. Or we can say this kind of arrangement of atoms will repeat itself throughout the crystal. That is the meaning of long range order. The specific arrangement of atoms will repeat itself throughout the entire crystal. But the beautiful thing to note it down, can you see in the diagram, the beautiful thing to note it down, when you are moving in x-axis, you are getting this kind of arrangement. You can see this arrangement. One circle is there, one dot, one circle, one dot, one circle, one dot, one circle, one dot. You can see that. But when you are moving in y-axis, then the arrangement is different. Now you are getting circle, 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 circle. Understood? The pattern is fixed. Pattern of atom is fixed. Along x-axis, the pattern of atom is fixed. It's fixed. But when you are moving in a different direction, you are getting different kind of atoms. When you are going in x-axis, you are getting different pattern. When you are going in y-axis, that is fixed only. Y-axis, then you are getting different, you are interacting with different kind of atoms, right? Now this is very very important point. So what is let me conclude again. What is a long range order? As you can see, this is specific pattern in crystalline. This specific pattern in crystalline is repeating itself throughout the crystal. You can see that throughout the crystal. But when in crystalline solid, it is observed experimentally, when in crystalline solid you are moving in different direction, you are getting different kind of arrangement of atoms. And guys, this thing influence, or this thing has a significant effect over the physical properties. Like, so what is the meaning, right? So for solids, we can define different type of physical properties. Let's say it's resistance, let's say it is refractive index, let's say it is conductivity. So basically the value of physical properties depends upon the pattern of atoms, depends upon the pattern of atoms, right? So in crystalline, if you move along x-axis, you will get different values of physical properties, but when you move along y-axis, you will get different types of different values of physical properties. Now why? Because arrangement of atom is different. You can see it directly from the structure. I think that is crystal clear. When you move along x-axis, different arrangement. When you move along y-axis, different arrangement. Since the arrangement is different, then that is why the properties of different physical the values of different physical properties is not same in a different direction. And my dear friends, this property is called anisotropy. Very, 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 very important question for CBSE exams. Right? This property is called anisotropy. So let me explain to you what is anisotropy. The value of different physical properties, the value of different physical properties is different in a different direction because of different types of atoms, in a different direction. This property is called anisotropic nature, and it is observed in crystalline solids, right? And why? The reason is basically, the reason we can say that also because different atoms we are getting in different direction for crystalline. But guys, on the other hand, amorphous solids have short range order. What kind of orders for amorphous solids? Short range order, right? Short range order means, let me explain to you first what is the meaning of short range order. A specific pattern. There will be a specific pattern, means a fixed pattern of atoms, specific pattern of atom. It will repeat itself, but not throughout the crystal. For a small distance it will repeat, then the pattern will change, then next type of pattern, next type of pattern, next type of pattern. This is the meaning of short range order. So crystalline solids have long range order, but amorphous solids have short range order, right? Now if you see that amorphous solids atomic arrangement, this is experimentally it's proven, so I'm just showing you the picture. If you see the amorphous solid atomic arrangement, yes, it is quite it is not repeating throughout the crystal. It's not repeating, you can see it's changing. But the beautiful thing here to notice is, since it is short, so when you are moving in different direction, suppose you are going in x, you're getting same kind of pattern. When you're going in y, you are getting same kind of pattern. When you're going in z, you are getting same type of pattern. So because of this, what is happening? So because of this, if I ask you, will the value of physical properties same or not? So you're like, sir, it has to be same, because types of atom that we are getting in different direction is same, right? It's same. You can see in amorphous. Atomic arrangement is irregular, but because of short range order, the types of atoms in different direction, we are getting same. It means the value of different physical properties in different direction will be same, and this property is called isotropic. This property is called, guys, isotropic nature. I hope this is clear to you. Very, 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 very important. What do you understand by long range order? Can you answer it? Right? What do you understand by short range order? Can you answer it? Why crystalline solids are anisotropic nature? Can you answer it? Why amorphous solids are isotropic in nature? Can you answer it? Ask yourself. If you can answer it, it means you understood. Right, guys? Okay. Now, the last point that I'm going to discuss with you is that crystalline solids, as you can see, crystalline solids are true solids and amorphous solids are pseudo solids. And this is because of the properties, because of the definite arrangement of atoms, we are calling them true solids. And for amorphous solids, irregular arrangement of atoms, we are calling them pseudo solid, right, guys? Okay, so one point is not mentioned in NCERT, but they also target in your CBSE exams, is that guys amorphous solids are also known as supercooled liquid. Amorphous solids are also called supercooled liquid. Amorphous solids are also called supercooled liquids. Supercooled liquid. Now, why we call them supercooled liquid? So we will see that, right, guys? So this is all about the types of solid, that is crystalline and amorphous. I hope you understood it.